This is John Nielsen for Data Analytics 30. I was just going over Unit 2 project. So I just do all my imports at the top. And I'm just going to kind of click through until we get to something interesting. Okay, as you can see, that it imported correctly. Here's the 19 columns. Similarly, we're looking at the sales data right here. Okay, this is the dictionary that I included that went with everything. It shows the data type and what exactly the variable means. We did this similar data type for the house sales info. Next, we copied to a new data frame and started cleaning. As you can see right here. Right. And those data types copied correctly. This is our cleaning plan. Basically, we're going to lowercase everything and then snake case it. I realized after the fact that I probably could have just downloaded the column names into a file and just run through it and done them that way. I did it manually. I'll go through that real quickly. I also did some abbreviation. All right. We also did a few checks on things that were unique and double check some data type stuff. Here's the info on which data types we might consider changing. So I had several types that were clearly not graded types. For instance, some of the object types could have been changed to categories. You can just see what I was thinking of right here. And then we went ahead and checked some of the missing data types. I just commented them out after I used them, so we'll comment them back in and then run them. So I will check. I'll just run a couple just as an example. Let's go ahead and run that. So as you can see, this is the sum of all the missing data types we've got right here. And we'll do the same thing for the sales data. And so there's 4 missing ones in the sales data. So those are some of the missing values we need to fix. The next thing we're going to do is detect outliers. I already did that down here, but I'm just going to comment some of them back in and try them really quick. So we'll do grade as for instance. No, not grade. Let's do square foot. Tends to be one of the biggest ones. So, well, actually, let's do year built. That works. As you can see on year built, we've got a really bad outlier down there. You can't see the one that's in 2050, but it is there. And we'll do another one as an example. Square foot buff. Here we go. Okay, square foot of the lot. Let's look at that. As you can see, there's a really big tail here. And this is in Seattle, next to probably close to where Bill Gates lives. So it's entirely possible that some of these are real data. But I think this one at the top is actually like half the size of Bill Gates' lot, so I decided to pare them down, and we'll go over that later. So this is basically what I discovered about my outliers. Bedrooms has a lot of outliers. Bathrooms has a long tail of outliers. The other thing that bathrooms has that's clearly an error is it's got some things where there's only a half bathroom or there's 0 bathrooms in multiple houses, and that's clearly nonsense. A half bathroom only includes 2 features. That would be like a sink or that would be like a sink and a shower, but no toilet. So you need at least a 3/4 bathroom. So some of those data need to be corrected. That's what the outliers discovered. And there's just a list of what I found. Then I made my data cleaning plan right here. So first I standardized the names. Then I changed some object types. I filled in missing values, and then I corrected outliers in bedrooms and bathrooms, and I did some pruning on square feet. And then this is just my clean test run approach, so I'll just kind of shift click through them. Alright, so this is the correcting of the spelling. I'll just run through this and I'll post it afterwards, although you can see some of the name changes down here. And by the end, they should all be there. Yep, and then right here, everything is corrected to lowercase, and we're dropping the unnamed column. And then this last bit right here I did because I had some extraneous spaces. All right, so let's do that. And one of the other things I noticed right here is it's easier to express your column change like right with this rather than the way I did it. Okay, so I'm just going to keep on clicking through and then I'll do a brief explanation again. So my general solution to the missing values was just to replace them with the median. The reason I replaced them with the median is that the mean would tend to be pulled upwards by the long tail in the data. In the case of things like zip codes or longitudes, I replaced it with the mode. I did the same for bathrooms. You can see it's running here, and then at the very end we do a check of all the things that are missing, and there's nothing missing in price, and there's yeah. So I'll do one more run. Run that real quick, and oops, rerun that. And there are no missing values anymore, so that ran correctly. We'll treat the outliers. Oh, pause real fast. I forgot to import right here in the line right above. Import it there, and now this runs correctly. And we'll do a. You can see that's running right. These are the things that are the outliers up here. So I discovered a few things that I didn't like. That 30 beds was probably an outlier. There are doubtless some really big homes up there, but I thought if the beds had the biggest z-score and everything else's z-score was much lower, I thought that was probably a so-called fat finger error. So I did two methods of pruning this, and I copied it into two different data frames just for my own interest. And I'll cover the differences I found at the end of that. Okay, as you can see, we're continually pruning by z-scores, and I'm doing a box plot, and you can see sort of the difference between a z-score prune and another prune when I get a little bit lower. So this is a prune kind of by like common sense values, and this is a z-score prune. And so one of the common sense values is there's something called a tiny house, and it's only about 200 square feet. And if anything was smaller than that, that's spurious. And Bill Gates' house was like 60,000 square feet, and if anything was bigger than a tenth that size, I decided that was spurious, so I pruned those. And the z-scores prunes it even more narrowly, so it doesn't capture the tail ends of what rich people do with their money. So that's why I chose to try the manual pruning. It didn't seem to make a huge difference, so in the future I might not do that. Okay, let's keep going through this. This is more pruning going on here, and you can see the difference in the frames after a manual pruning and a z-score pruning. And then we did a year build pruning. The manual one, Washington was founded in 1898, so that was my bottom cutoff year, and that was my top cutoff year. And the z-score actually didn't cut stuff out, so manual pruning was better. Okay, and then we can see right here when we're done pruning everything, we've got the info when it's done, and the difference between them is that when I pruned it with z-scores and just threw them away, I got about 20,600 entries, and when I did it by hand, it was about 21,000 entries. So I didn't lose that much data by just dropping things that were outside the norm. So in the future, I might just do z-score things. Okay, and that's the end of the data pruning, and then we did the categorical re-expression. So I had three categories I chose to do. The zip code, and I just turned that into a string. And then these are the re-expressed ones. I did waterfront, whether or not it was on the waterfront, its view, and its house condition. And the view and the house condition were ordinal, in that there was a best and a worst. So I just assigned the best a 1 value and the worst a 6 value. And the waterfront, I just assigned a 0 or 1 for yes or no. All right. And so this copied it into a new data frame, which I called WaterDF. And I end up attaching that to my data frame when I'm done. and this is my mapping to my mapping replacing the original column with this new column right here. And I will just really quickly post it underneath. So let's do. As you can see, the house condition got replaced with a numerical value, and the view also got replaced with a numerical value. Okay, this right here is my summary of it. Then before I did the regular merge, I chose to merge. I chose to glue together the this thing right here, the clean house, and that water DF thing I made originally. So when you run all this, if you look, I've got a yes/no category now. And so I basically did a chained merge. Then we run this right here, get that, and then we run our CSV, and it saves successfully, and that's it.